Section 6.8, Linear Inequalities and Systems of Linear Inequalities. Linear inequalities in two variables. The solution set of a linear inequality in two variables is indicated on a coordinate plane. Previously, when you graphed this, you would just graph it on a number line, but that's because you were only dealing with one variable, like x greater than 2. So you could just show your 2 with an open circle and shade to the right. Now that you're going to have both an x and a y, you'll have to graph it on a coordinate plane. An inequality that is strictly less than or greater than will have its solution shown as a half plane. The half plane is a set of all points on the side of a line. I'll show you an example. Let's say that we were looking at y is less than x plus 1. When you go to graph this, pretend you're just graphing y equals x plus 1. So you would graph your y-intercept at positive 1. You would use your slope, which is 1 over 1, to go up 1, right 1, until you've got several points on your line. Then in this situation, since we want all the items that are smaller than this line, we have to use a dashed line because the points on the line are not included in the solution set. Then on top of it, you have to shade. And since we are looking for y's to be less than this line, we will shade to the left. And what we're showing here when we shade is we're showing all the solutions to this linear inequality. So basically, any point that's over here in the shaded region is considered a solution. Sometimes you'll have an inequality that has an equal to with it. So if you have a less than or equal to or a greater than or equal to, your solution set will be the half plane like before, but it will include the line. So to indicate that the line is part of the solution set, we use a solid line. Before, when we wanted the line to not be part of the solution, we used a dashed line. So let's look at an example like this really quick. Let's say I gave you y less than or equal to negative x plus 3. You would start at your y-intercept of 3. You would use your slope, which is negative 1, and go down 1, right 1, down 1, right 1. Because the solution set is included, we get to use a solid line. And again, this is a less than or equal to, so we're going to shade under the line. If it gets more complicated, if it's not in y equals mx plus b form, then we're going to use a test point method, which I'll show you on the next example. So any point that lands on the line or in the blue shaded region is going to be a solution to the system. So obviously there's infinite solutions for this problem. So when you go to graph these linear inequalities, first thing you want to do is you want to mentally substitute an equal sign for the inequality sign, plot the points just like you were going to graph the line. If the inequality sign is less than or greater than, you use a dashed line. If the inequality sign is less than or equal to or greater than or equal to, use a solid line. Then you can use your test point method. I would only do the test point method if you are not in y equals mx plus b format. So what you do is you select a test point, you substitute the point in for the x and y values of the equation or inequality. If it makes a true statement, shade that area of that side of the line. If it makes a false statement, you should shade the opposite side of the line. All right, so let's look at an example. This one is not in y equals mx plus b form. So what I would probably recommend that you do is put it in that form, or you can find your x and y intercepts. And again, they recommend that when you're graphing that you just ignore the inequality and go with an equal sign. So remember, if you're looking for your x-intercept or where you cross the x-axis, you zero out the y, which is going to tell you that you cross the x-axis at 4. If you are looking for your y-intercept, you zero out the x, which tells you you're going to cross the y-axis at 2. The inequality does not have a line underneath it, so you need to use a dashed line when you connect your 2 points. And then you have to decide what side of the line to shade. Do you shade under the line in region 1, or do you shade above the line in region 2? So they're asking you to use a test point method. So I typically select the easiest test point I can think of, which is 0, 0. And what you do is substitute that in for the x, the 0 in for the x, and the 0 in for the y to see if it makes a true statement. Is 0 plus 0 smaller than 4? That is true. So if you got a true statement, then you will shade that side of the line where the test point was on. If it creates a false statement, then I would have shaded region 2. If you don't like that approach, then the other option is to just solve the inequality for y. And once the y is isolated on the left, you can just follow the direction of the inequality sign. So if it's a less than, you shade under the line. You have to have the y alone before you can do that shortcut. All right, so let's look at this problem. Y is smaller than x. So notice there is no y-intercept. So if there's no y-intercept, that means that you are going to cross the y-axis at 0. So I will touch the y-axis at 0. The number in front of the x is a 1, so my slope is up 1, right 1. The inequality sign does not use a line underneath it, so I will need a dashed line. And since the y is alone, you can use the shortcut technique here. We want to be smaller than the line. So smaller than the line can be considered under the line. If you wanted to do a test point method, for example, let's test the point 0, 2. So you'd have to let the x be the 0, and you'd have to let the y be the 2. Notice that this is saying 2 is smaller than 0. That's false. So we would not have shaded that region because we got a false statement over there. Now they're going to bump you up to systems of linear inequalities. When you're dealing with a system of linear inequalities, you're just going to have more than one inequality at a time. So essentially, you're going to select one inequality. You're going to go through the whole graphing situation. Replace the inequality with an equal sign, draw the graph of the equation, draw the graph of a dashed line or a solid line. You get to repeat the process with the other line. Select your test point to decide which side of the line you're going to shade. Repeat it with the other inequality. And then your solution is going to be where the two shaded regions overlap each other. So let's look at an example. I gave you the inequality y less than negative x plus 1, and x minus y is less than 5. Okay, so the first one is in y equals mx plus b form. So let's just go ahead and graph that by plotting our y-intercept at 1. We would need our slope of negative 1, so down 1, right 1. Again, this is a dashed line. And the y is isolated and we're using a less than sign, so we'll shade under the line. Okay, your second inequality is not in y equals mx plus b form. So if you want, you could just put it in that form by subtracting the x to the other side and dividing by negative 1 to get the y alone. Now remember, that'll make the x become positive and the 5 become negative, but when you divide by a negative, it flips your inequality sign. So that's why we cannot shade until we have the y alone, because sometimes the inequality sign will change directions. So we should intersect the y-axis at negative 5. We have a slope of positive 1, up 1, right 1, up 1, right 1. Dashed line because it does not have an equal to sign underneath. And if you're using the shortcut, our solution is that y should be greater than this line, so that would be above the line. Now, There's a lot of shading on this graph, but the true solution is the shading of the overlapping region. So just this triangular wedge where the two shaded regions overlapped, that is your solution set.